Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today in this video, I am going to give a lecture on the subject Design and Analysis of Algorithm. The subject code is AD3351. This paper will be coming in second year, third semester. The content in this subject is 5 units. The unit 1 is introduction, unit 2 brute force method and divide and conquer method, unit 3 dynamic programming and greedy technique, unit 4 iterative improvement, unit 5 is limitations of algorithm power. So the course objective of this subject is the first one, to compare different algorithms for the same problem based on time and space complexity and select the most efficient solution. The second objective is to understand and apply basic algorithm design strategies such as brute force method and divide and conquer technique. The third objective is to learn advanced problem solving techniques like dynamic programming and greedy methods to solve complex problems efficiently. The objective 4 is to use methods that progressively improve solutions such as local search and heuristic approaches to solve optimization problems. The fifth objective is to understand problems that are computationally hard or unsolvable and explore their strategies like approximation, heuristics, and problem reduction to manage such limitations. The next one is course outcomes. At the end of this course, the student will be able to analyze the efficiency of recursive and non-recursive algorithms using mathematical methods such as recurrence relation and asymptotic analysis. Next, the students can evaluate the efficiency of different algorithmic design techniques including brute force, divide and conquer, decrease and conquer, and transform and conquer approaches. Next, students can implement and analyze algorithms using dynamic programming and greedy techniques to solve computational problems efficiently. The next one is the students can apply iterative improvement techniques to solve optimization problems by progressively enhancing solution quality. The final outcome is the students can able to access the limitations of algorithmic power and solve complex problems using backtracking and branch and bound techniques. Next, come to algorithm. So what is an algorithm? An algorithm is a finite step-by-step set of well-defined instructions used to solve a problem or perform a specific task. In simple words, an algorithm tells how to do something step by step to get a desired output. So the definition for this algorithm is: an algorithm is a sequence of unambiguous instructions that, when executed, produces the output for the given input in a finite amount of time. So there are some key characteristics of an algorithm. They are input, output, definiteness, finiteness, and effectiveness. So input means it should take 0 or more inputs. There should be a valid inputs and it must be clearly specified. Next, output. Algorithm should produce at least one output. Third one is definiteness. So in algorithm, each step should be clear and unambiguous. Then fourth one is finiteness. There should be a termination after a finite number of steps. The fifth one is effectiveness. Here each step should be simple and executable. So next one is fundamentals of algorithmic problem solving. So this shows the algorithm design and analysis process. Here a step-by-step explanation is given. So first of all, the step 1 is understand the problem. Step 2, decide on. Here there are 4 subdivisions. They have to decide on computational means, exact versus approximate solving, data structure and algorithm design technique. Then step 3 is design an algorithm. Step 4 is proving the correctness. Step 5 analyzing the algorithm. And step 6, the final step, is coding the algorithm. So here we can see step by step. So first one is understanding the problem. This is the first step in designing of algorithm. Read the problem's descriptions carefully to understand the problem statement completely. Next, clarify the doubts about the problem. Then identify the problem types and use existing algorithm to find solution. Next, input to the problem and range of the input get fixed. So ensure the problem is fully understood before moving forward. A wrong understanding leads to a wrong algorithm. Next step, decide on. Here there are 4 subdivisions. The first one is computational device. So in RAM, instructions are executed one after another and algorithm designed to be executed on such machines are called sequential algorithms. Operations are executed concurrently in parallel algorithms. Here the choice of computational device is mainly based on space and time efficiency. So if decisions are not satisfactory, we may return to problem understanding. So the next one is choosing between exact and approximate problem solving. The next principal decision is to choose between solving the problem exactly or solving it approximately. An algorithm used to solve a problem exactly and produce correct results is called an exact algorithm. If the problem is so complex and not able to get exact solution, then we have to choose an algorithm called an approximation algorithm, that is produces approximate answer. For example, extracting square roots, solving non-linear equations and evaluating definite integrals. So the next one is algorithm design technique. An algorithm design technique is a general approach to solving problems algorithmically that is applicable to variety of problems from different areas of computing. So there are many design techniques like dynamic programming, greedy technique, divide and conquer, etc. So next one is designing an algorithm and data structures. So though algorithms and data structures are independent, they are combined together to develop a program. Data structures, here the choice of proper data structure is required before designing the algorithm. So implementation of algorithm is possible only with the help of algorithms and data structures. So next step is design an algorithm. to develop a step-by-step procedure to solve the problem. So here there are three ways to specify an algorithm, that are natural language, pseudocode, and flowcharts. So first of all, we can see what is natural language. So it is very simple and easy to specify an algorithm using natural language. But many times specifications of algorithm by using natural language is not clear, and thereby we get brief specifications. So next one is pseudocode. So pseudocode is a mixture of natural language and programming language constructs. Pseudocode is usually more precise than natural language. For assignment operation, the left arrow is used. For commands, two slashes is used. Then if condition, for loop, while loops are also used here. The next one is flowchart. So in the earlier days of computing, the dominant method for specifying algorithms was a flowchart. Flowchart is a graphical representation of an algorithm. It is a method of expressing an algorithm by a collection of connected geometric shapes containing descriptions of the algorithm steps. So if the design is inefficient or unclear, revise earlier decisions. The next step is proving an algorithm's correctness. So once an algorithm has been specified, then its correctness must be proved. And algorithm must yield a required result for every legitimate input in a finite amount of time. So this step ensures the algorithm is logically sound. Next one is analyzing the algorithm. For an algorithm, the most important is efficiency. In fact, there are two kinds of algorithm efficiency. They are time efficiency and space efficiency. Time efficiency indicates how fast the algorithm runs, and space efficiency indicates how much extra memory it uses. The efficiency of an algorithm is determined by measuring both time efficiency and space efficiency. So factors to analyze an algorithm are time efficiency of an algorithm, space efficiency of an algorithm, simplicity of an algorithm, and generality of an algorithm. Next, the final step, coding an algorithm. Here, the implementation of algorithm is done by suitable programming language like C, C++, and Java. Here, we have to follow good programming practices, then test with different inputs and edge cases. Here the process is iterative, it's not strictly linear. You may go back and revise decisions, design, or analysis until an optimal solution is achieved. So in the next video, we can see important problem types. Thank you.